Many people think an escalator works like this. Two wheels drive a chain, and steps are attached on the outside. But when the steps reach the top, they would tilt forward, making it hard to step off. The same problem happens at the entry point. Since the issue occurs at both ends, designers initially tried extending these parts. But in practice, it failed. The escalator became unusable. In reality, there are only two correct transmission systems. Let's break down one of them. First, the escalator is powered by a motor of about 50 kilowatts, rotating at just 10 revolutions per minute. This motor transfers torque to a larger gear that turns more slowly but with greater force. That gear drives the main chain. The chain is filled with small special rollers that pass smoothly through the gear teeth. These rollers also hold the steps in place, allowing them to rotate around their own axes. Behind each step, there is a second wheel that rolls along a dedicated track. On the slope, the track and the chain overlap, but at the top they separate, remaining parallel. As the gear rotates, the steps are flipped and begin their return path, meeting again at the starting point. This process repeats endlessly. You might have noticed that the handrail moves faster than the steps. That's because it's driven by a friction wheel. Over time, the wheel wears down, slowing the handrail. To compensate, manufacturers set the handrail speed about 2% faster than the steps, which is why when we hold on, our hands slowly slide forward. The biggest safety concern with escalators is the gaps, especially at the ends, where clothing can get caught. To address this, designers once tried adding triangular exit zones to guide passengers away from the front gaps, but this made it easier to stumble and twist ankles. The best solution has been grooves on the step surfaces, which interlock with a comb plate at the top. Even very small objects get lifted away, instead of being trapped in the gap. Modern escalators also use AC induction motors. These can switch between motor and generator. When many people are going down, their weight provides enough force to move the steps on its own. That mechanical energy then powers the motor in reverse, generating electricity. The heavier the load, the faster the motor spins. When the rotor tries to exceed the magnetic field speed, a countercurrent is created, generating a braking force. At that point, the motor becomes a generator, sending excess energy back into the building's internal grid, even powering the upward escalators.